Welcome to Autodesk University 2021, and welcome to our class. Today we're going to just demonstrate the workflow of InfraWorks, Civil 3D, Revit, and Robot Structural Analysis Professional in the context of building a house on a lake. My name is Matt Kolberg. I began my career in 1993, worked as a civil consultant, multidisciplinary. We did things like land development, roads, underground utilities, and land planning. Since 2006, I've worked as a technical specialist for an Autodesk reseller here in Canada, where I specialize in all the software that civil engineers typically need. Civil 3D, InfraWorks, Map 3D, Recap, and most recently, the Autodesk Construction Cloud. That's enough about me. Take it away, Lina.
Thanks, Matt.
I'm currently the BIM manager at Diamond Schmidt in Vancouver, BC. I have many years of experience in architecture, interior design, building systems, and building manufacturing, specializing in BIM technologies. I have trained and coached many teams in multiple design and subcontracting AEC firms, and I've also been speaking at AU for a few years now. I'm going to pass it to the next speaker.
Hung.
Thank you, Lina. Hello, everyone. I'm Hung. As you see, I have many years of experience in Autodesk products, 27 years. I work with architecture and manufacturing fields. I've been doing a lot of work relating Revit, Inventor, Fusion 360 areas, and do a lot of simulation for the past few years. I presented in RTC, Indian Festival of Architecture, BIM, and of course, my favorite is Autodesk University. I think I started from 2013 until now with it 2021. Back to you, Matt.
Today's class will showcase the interoperability between several of the Autodesk AEC collection software applications, such as InfraWorks and Civil 3D and Revit and Robot Structural Analysis. We're going to create a building site in InfraWorks. We'll place a Revit building on that site. We'll do some grading in Civil 3D, and we'll use Robot Structural Analysis to analyze the conditions and design a retaining wall. We're going to integrate all those models at the end inside the InfraWorks model, and we'll use the Autodesk Construction Cloud to store all of our data in the cloud. The class objectives for today are to learn InfraWorks and the other software packages together and figure out what their interoperability goals are and tools. We'll talk about a workflow that takes models from each of those applications and integrates them together. We're going to learn the robot structural analysis in terms of a retaining wall, and finally we're going to learn how to use the new Autodesk Construction Cloud to store all your data in the cloud and to share that data between multiple teammates. And here's our agenda. First, we're going to generate the existing conditions plan inside InfraWorks. We will bring that model into Civil 3D because we have to do some basic grading there. We'll take the Revit building and place it into both Civil 3D and InfraWorks, and you'll learn how to place it accurately. The building in Revit and Civil 3D, they don't really speak the same coordination or the coordinate system language. So we'll learn how to coordinate the Revit model and the Civil 3D model using the Autodesk Shared Reference Point tool. We'll learn how to design building in Revit a little bit. We need to calculate earthworks in Civil 3D for the purpose of calculation in Robot Structural Analysis for the retaining wall. And then finally, we'll combine all those models in InfraWorks for the final visualization. Here's the completed project on the lake. It was designed by architect Omar Take. It's located in Anmore, British Columbia. The property area is 7,000 square meters and the building is 600 square meters. Let's begin. Often, the first step in creating an InfraWorks model is to do so using the model builder. You can supplement the model builder data with more accurate survey data once you receive it. I'll open the model builder. I'll zoom in to find an area. There we are. I'll give it a name. And if you're going to be using this with Civil 3D, it's critical that you select a coordinate system. I'll choose UTM NAD 83 Zone 10. That's appropriate for this area. Now you'll notice when I zoom out, the Create Model button is unavailable because our area is greater than 200 square kilometers. At least that's the current limit with the model builder. All right, now it's available. When I click Create the Model, it will be created. Now, there's a chance you don't know exactly where the area is, or you have something in AutoCAD or Civil 3D, such as a closed polyline that defines the outer limits of your model. You can use this tool to import a shapefile exported from Civil 3D. This way you don't have to browse the map. I'll close the model builder and I will wait to be notified when my model is ready. And here's my model. Showed up in the home page of InfraWorks. I also got an email that said it was ready. Right now you can see it's stored, well, nowhere yet. It's going to ask me where I want to store it once I click it. Do I want to save it to Autodesk Docs or do I want to save it locally? Your choice. For this demonstration, I'm going to save it to Autodesk Docs. In fact, I'm going to hit cancel because I already have one done. And the icon looks like this when you saved it to the cloud, and it looks like this when you saved it locally. Let's open it up. This model has completely regenerated. The first time you open up a model from the model builder, it's going to take some time to download all the files and apply all the materials and such. And there it is. Within the Autodesk Construction Cloud, the InfraWorks model is stored as an IWM file. And of course, locally, within Autodesk Docs, that IWM file is still available. However, this is not the file that you use when launching and opening the model from within InfraWorks. When you create the model using the model builder, or any model for that matter, when you open the file locally using InfraWorks, the model is actually stored within your documents in a folder of a certain number. This number was created by InfraWorks when the model builder was used to generate the model the first time. The SQLite file is the file that you have to open with InfraWorks to perform any edits. After you make those edits, only the SQLite file is modified. Because we're not editing right within Autodesk Docs, changes aren't automatically synchronized to the cloud. To make that happen, you use the Synchronize button right here inside InfraWorks. Your edits will be uploaded, available for other users. Once synchronized, I can open this link either in InfraWorks or I can open it in my browser using the Autodesk Large Model Viewer. And it looks something like this. For a large model, the performance is surprisingly good. This model can be shared with team members or users outside your organization in a read-only fashion. If they don't own InfraWorks or don't have access to it, it's okay because the model is being viewed right there in your browser. In order to perform detailed design in Civil 3D based on an InfraWorks model, you need to import some of the InfraWorks components into Civil 3D. There are several prerequisites before you can actually select the InfraWorks model and import. One, you need to assign the same coordinate system you assigned inside InfraWorks. This is done in the Civil 3D Settings tab by right-clicking your drawing and going to Edit Drawing Settings. Now this project is near Vancouver, British Columbia, Canada, and I know the coordinate system code, UTM, NAD 83, Zone 10. The second prerequisite is to zoom in roughly to the area that you want. Notice my coordinates are turned on, roughly 500,000 easting and roughly 5.4 million northing. That's near where Vancouver is. To make it maybe a little bit easier to navigate, you can also turn on the BIM imagery right from within AutoCAD. In order to do this, the same prerequisites apply. You have to set the coordinate system and you have to be roughly zoomed in. If you're not zoomed in, when the image turns on, you can be able to zoom around and find it. All right, there's our lake, and that's the approximate location of the house and the InfraWorks model. Again, this step is optional, but I find it helps. Now I can import the InfraWorks model. In the Insert Ribbon tab, I can click the Open InfraWorks Model tool. I'll browse for the model. Now, if this stuff is all good, we're ready to go. If you haven't set the coordinate system correctly, you'll find an error here. Also, you need to close the InfraWorks model. You cannot be editing the InfraWorks model in InfraWorks when you do this. Now we can choose. Do we want to bring in the entire InfraWorks model, or can we choose some of the components? I can choose the area of interest if I want to limit the geographical area, or I can actually select the objects I want to import. The InfraWorks model is going to contain road center lines and building footprints and terrains and a bunch of potentially other things. I'm only interested in the terrain, so I can turn off all of the other components if I wish. I can save this selection for use later. I'm not going to bother this time. And when you're ready, we'll just click the Open Model button. And here it is, all imported. It all seems to line up nicely with the imagery that I have. And there's my InfraWorks model. If there are objects that you don't need, like road center lines or other terrains, feel free to remove them at this point. I've removed the objects that I don't need. And the next step in Civil 3D would be to import the Revit building and do some basic grading for the building pad and surrounding area. In order to perform some basic grading of the site, we need to import the model the Revit designer has created. The coordinate systems between Civil 3D and Revit are rarely synchronous. Civil 3D often uses some kind of UTM coordinate system, and the Revit model is generally designed near 0, 0. So when you XREF a Revit model into Civil 3D, it will rarely line up properly. In fact, you can't actually XREF a Revit model into Civil 3D. There are a couple of choices, one being the Revit designer exports to a DWG, which can then be XREF'd. Or we can append a Revit model into a Navisworks model and save it. The Navisworks model can be XREF'd into AutoCAD. What's the advantage? Well, using Autodesk's shared reference point, we can define 2 points in the AutoCAD model and the Revit model and tell the software these 2 points are synchronous. When the Revit designer exports to a DWG, as long as those shared coordinates have been defined properly, you can XREF it 0, 0 and everything will line up properly. I'll show you the Navisworks option first. Here we have a blank Navisworks model. All I need to do is append the Revit model to it. And there it is. We just save it as an NWD file. There are actually several options in Navisworks: NWC, NWF. NWD is generally the best option for XREFing into AutoCAD. I'll just attach the Navisworks model. Make sure I choose Navisworks files. Now, when this comes in, this model and the AutoCAD model are not synchronous, they are not coordinated, so we're going to have to specify an insertion point and potentially a rotation as well. I'm going to click cancel so as not to have to show you that, because it's really just a manual process of eyeballing where you think the building should be. The other option, once the Revit designer has exported the DWG, it's still the same procedure of just XREFing that DWG file. There it is. Again, it's just a matter of attaching the file and manually moving it and rotating it so it fits on your property, assuming you have not yet set up the shared reference point. We'll discuss the shared reference point a little bit later. And here's the Revit building inserted into the AutoCAD drawing on top of the InfraWorks terrain. I've already done some basic grading, and the grading that you'll do in Civil 3D is just your typical grading. Create a feature line for the building pad, do some daylights. I've moved the Revit model horizontally and vertically in order to line up with that building pad. We can now create the shared reference points in Revit so that everything will line up nicely in the future. We'll talk about that later. Now we're going to place that same building in InfraWorks. Unlike AutoCAD and Civil 3D, we don't have the shared reference point tool, so the placement of the building is somewhat manual. First, I'll drop the Revit model onto my InfraWorks model. There it is. There's our data source configuration dialog box. And we now have a choice. We can interactively place it. Essentially, you're eyeballing where it goes. Or we can enter some coordinates if you know where they are. I'll click interactive placement. You'll see the building appear, and essentially I can just double click and place it anywhere I like. You can then use the gizmo to move it X, Y, and Z and place it correctly. I'll hit escape. Now, there is a procedure outlined in Autodesk's documentation that shows exactly what to do here. Here's the web page. You'll find the link in the PowerPoint. And it goes through the exact procedure. So here under coordinate system, you choose X, Y, feet or meters, depending on the units your Revit model is built on. The coordinate system for us is UTM NAD 83 Zone 10. And right here, you enter the Revit base point. Now, you're going to have to work with your Revit professional to get those. Documentation, it shows that right here. X, Y, and Z value from your Revit project base point. Now, honestly don't know exactly what those are right now, so I'll just type in some values. The Z, whatever elevation your Revit model base point, it should be 59.515. And then right here, if there is any rotation value based on your Revit's project north versus true north. So again, you're going to work with your Revit professional to find these values. When you're ready, click close and refresh. For me, the building has already been placed. And there it is. Now let's talk about the Autodesk shared reference point, the tool that allows the Civil 3D drawing and the Revit model to be synchronous in terms of their X, Y, Z coordination. Because the Revit model is designed near 0, 0 typically, and the Civil 3D drawing is set up in some UTM coordinates. They almost never line up. So the shared reference point will allow this to happen. Now, you have to decide here in Civil 3D, or even in Revit as well, as long as you know which coordinates they are. You have to decide which 2 points to specify. Now, it's a good idea in Civil 3D, if you're doing it this way, to isolate the Revit model itself so that you're not accidentally picking other points. There we go. I'm going to use that as my first point and that as my second point. The Shared Reference Point tool can be found in your Civil 3D Toolspace toolbox under the Subscription Extension Manager. I'll run the tool. And I'll pick the origin point. Now, the thing about this particular Revit model, the Z value here and here are for all intents and purposes the same, but they're off by like less than a millimeter. The thing about this Shared Reference Point tool is the elevation has to be exactly the same. So when I'm specifying the origin point, I'm going to use the point filter called .xy. This may not be something you've ever heard of before, but I'm using my mouse to define the xy, and I'm going to type in the z. So I'm going to use my mouse to define the xy point, and now it says z. And I know the elevation of that is supposed to be 59.551. Now the second point I'll define is this one here, and I'll do the same thing. .xy, I'll use my mouse to define the x and y, and I'll type in 59.551. Because if they're not exactly the same, the tool will throw an error. There we are. I've specified everything in meters, and the tool is going to create an XML file for us. I'll just name it something intelligent like BLDG2. And now my Revit partner can use that XML file to define the shared reference point in Revit. And Lina will show you that procedure.
I'm going to go to the steps of the InfraWorks context that we created to be used in Revit. That was prior to sharing it with Matt. That was when at first we wanted to test the location and then see if it works for the project. We started by creating the InfraWorks model using the model builder based on the project location. We interactively positioned the Revit model in InfraWorks. We created the grading, a study grading basically, at the location of the house to take it into Revit for further study. And we exported the InfraWorks model to FBX. We exported it as two files, one for the ground and one for the buildings. Now, what did we do to bring that export into Revit? We cannot bring the FBX files directly into Revit. So we used Format to import the ground into Format. We imported the ground FBX file into Format. We also brought in the house model. And then from Format, we exported the ground file as DXF, and we exported the house. We could have exported it as DXF or as DWG. Doesn't matter. Now in Revit, we imported the DXF model and we positioned it and used it to create the topo. And then we created the pads in Revit and adjusted the topo grading as needed. Now that the XML file is saved, in Revit, I will run the import shared coordinates tool, select the same 2 points selected in Civil 3D and make sure that they are selected in the same order. I will open the XML file generated by Civil 3D and will set it as the new location. I will then link the topography that was exported from Civil 3D. So Matt have already created the shared coordinate point for me, the reference point. So I'm going to open the file. I'm going to open the house, the Revit model. There are two ways to do it. Right now I'm doing it within the Revit model of the house directly. There is another way where I can open the site file, place it in the site file. But at the moment, I'm going to bring it in here. I'm zooming in because I'm taking those 2 points. We decided on those 2 points for alignment. So I'm going to go to the add-ins, select the import shared coordinates from file, and I'm going to select, I need to select the origin and the alignment point. But
When I'm in this state, I'm not being able to select the point. So what I need to do, I need to create a line. Okay, so I'm going to go to architectural, model line. I'm going to quickly create a line, place it on main level, and I'm going to pick this line here and escape. So now I'm going to go back to the add-in. Okay, actually I'm still in the command. I'm going to go back. I was still in the command before. So I'm going to select the origin point to align to, and I'm going to select a point for the direction. And I'm going to browse to the location of the XML file that Matt had created for me. I'm going to select it and open it. That's fine. I opened it. It's there, but it's not enough. I have to go to manage. I have to go to location. And under site, I have to select it and make it current. Okay. Okay. Nothing is happening. I don't see any topo. Let me just quickly change the spot elevation here. I'm going to change the spot elevation. It is currently a project base point setting. I'm going to change it to survey point, and we're going to see that the value is changing. So my next step is to go to the Insert tab and link the topography. I'm going to link the topography from the file that Matt saved for me on ACC. It is the surface file FG, and link it. As soon as I click link, I'll select align, and now the topo surface is positioned at the right location.
Thanks, Lina. Now I'll ask Hung to show the next step in our workflow on how to create and analyze the retaining wall.
So now the scenario between Civil 3D and Revit already done. The position has been established. And now the next step we need to do is to design a retaining wall around the Revit house. So that's it, my part. In the demo, this is the step that I will demonstrate. How to design a retaining wall in Revit, where I will take the Revit architectural model from Lina. I will then link it to a brand new file, structure Revit file, and I will copy and monitor the wall that she established in the back of the building. I will show you in the demo. And I will take the wall and set up a Revit structural electrical file with load and some support and so on. And from that, I will link the Revit model into SA to do the analysis. In this demonstration, I will keep the analysis very, very simple. The reason behind it, we don't have time, and it's not about the Revit analysis. It could be very complicated because when you design a retaining wall, you have to look into stability and rotation, stress calculation. You need to do the analysis of punching and shear and uplifting and sliding and so on. So many aspects of designing a retaining wall, and as I can handle them all. However, that is another topic. In here, I just go simply through the workflow just to show you the workflow only. So with that in mind, let's jump into see the demo. From Revit, after receiving Lina's model, I will start with a structure template, and I will use Revit link model and link on ACC, the house that Lina posted for me, and it's called House on the Lake AU-22. So link it to origin into my Revit structure model. Couple of warnings showing up because of the overlay of the land. I will just turn it off. And now let me show you the three wall in the back that I need to do the analysis. Basically, those wall as Revit architecture wall, and I like to copy and monitor the wall. So you copy and monitor and do a multiple copy for the wall and finish the task. And now just double check everything, and I see it actually monitor Lina model. And about time for me to turn the link off. To make it simple, I also turn on the level up and so on. So as you will see that the wall is currently at the base at 8-inch wall. So now let's go to the analytic model in structure, and I also turn the Revit model off. And I'm missing the floor. The reason behind the floor, when I copy monitor, even though I change it to 6 inches concrete, and check on the material, it's actually concrete, but I cannot analyze it simply because it's not a structural element. Turn it on, and now I will have the analytic model in the background. So now I'm going to the Analyze tab, and we'll show you how to set boundary load and locate. So with the boundary support, I add to support the bottom, the foot of the two wall and the floor. And the next step I will do is to add some load to the back of the wall. I create a load case, and in Revit you can create any load case that you like. In here, I just use a symbol, non-engineering word. I call it soil load just for fun. And it could be a dead load, light load, wind load, whatever. But to keep it simple, I just choose dead load for that load case. So now it's about time to apply them. I use hosted area load and apply to the back of those two walls. And you will see that it actually, the direction is not correct. So I fix it. So it's supposed to be a minus on the y direction. And now you see that I applied that soil load on it. So the model is color ready to be analyzed. So let's go back to the 3D model, turn off the analytic model for a second and look into the structure. And I noted that on the copy monitor, it doesn't have the proper material. So I assign all of them to you a proper material. Let's say you the concrete normal wave 5 KSI. And I will do the same for all the three objects. And now it's about time to send the model to R8 for analysis. So you see, you can set up all of the options and so on. And when it's ready to go, just hit the button and let it export the model to RSA. So it's a real-time recording. So let's see how long it takes. Only 3 objects, so it's going to go really fast. I have a little warning there. It doesn't belong to any storage. To remove the error, I just simply delete the level 2 in RSA model. And there's no warning left. So let's just show you the soil load that from Revit is also come across. And you see it minus 1 kip on the Y direction. So the next step you need to do, and when you do an RSA, you need to do some meshing setup. I set it 5 feet, and I use a square in rectangular contour, and ready to do the mesh routine to mesh the object. And now it's about time to do a calculation. So it's simple model, so it goes really fast. So now I can go and show some results. I show the moment on XY axis, and you see some results already shown there. And you can show displacement and so on, and based on the soil load. Okay, so let's clear them out. So now the next step, I noted that the wall, based on the calculation, the wall and the thickness of the floor is kind of thin. So it's only on a 6 inches concrete. So inside RSA, I decided to choose to change on of the thickness for this retaining wall and the floor slab with the 12 inches concrete, and we do the calculation. After checking out the mapping on the moment and so on, I found the result is getting way better. And now it's a good time to send everything back to the Revit structure to see if it's good. But before doing that, I want to save the model on our ACC for further analysis. So I just simply give it a name called walls and save it on ACC. So now go back to Revit, go to the 3D view, and the copy monitor is still there, and you see the floor and everything still on 6 inches concrete. But now if I link it back and update the model and the result from RSA, and if I hit OK, so I have the analysis package plus everything is going to be transferred. It will also update my Revit model. So after it's done, so now let's check it. You see now it turned that into a 12 inches concrete that is original set and override in RSA. So now it's about time for me to save that result onto ACC for Lina to do the copy, and she may need to replace the wall with the 12 inches wall instead of 8 inches or 6 inches wall that she originally set it up in this architectural model. As ACE also have a very nice reinforcement concrete design that calculate and recommended provided reinforcement for concrete. So let's take a quick look. So with the retaining wall still open, I just select one of the wall number 1, and I'm going to send it to the reinforcement calculation module. I'm filing it up, just simply calculate based on a simple case, and on the interface, you can see wall reinforcement, wall node, and the complete report that can be generated out of one of the nodes. With that wall selected, I will do a secondary calculation. Hit the calculation. It takes a bit of time, so now the results coming out, and you could view that the rebar now is embedded inside the wall, and it have multiple view, and then you can also assign if you want to override, you can always oversize different diameter for it, and it have a fully report on the wall node and so on, and it's very useful for a concrete designer. So now switch back to Revit. Assume that based on that report, I like to manually put the support that the precast concrete. I can use the module in the add-on in Revit called precast to calculate and subdivide the wall into panel. After the calculation is done, you can just simply select one of the part that the add-on divided for you, and go back to the precast and build the reinforcement behind that. You can configure it how the rebar will be built for you. In no time, the rebar will be built inside the part, and if you want to show them on your drawing, you just turn them to solid. In this case, I just select them on and filter on of the structural rebar out. And to show that, I just go to the visibility and turn on the 3D view on, And there you go, the complete reinforcement that is embedded inside my retaining wall. So it's a good time to send it back to the architect for copy and monitor. After a few rounds back and forth, and assume that the retaining walls are done and ready to be shared on ACC, Lina can now link my Revit structure model back to her model. She will copy, monitor, or even replace her original wall with my Revit model if needed. She can also continue to share and collaborate with Matt using InfraWorks on ACC. Matt, you can take over and conclude our presentation.
Thanks, Hung. So to finish off our class today, just a few cleanup items. Number one, you're going to update objects as they're edited. AutoCAD drawings, Revit models, GIS data sources if they've changed. Go into your data sources panel in InfraWorks and update. Now, for this model, for performance reasons, I've limited the model extents. In a moment, I'll restore those extents so we can see the entire thing. You want to do that before you create your stills and videos and sun studies. But I'll do the stills and videos first. Bookmarks, also another good thing. Save any previously set viewpoints that you quickly want to restore. The deck, the wall, the overall site, the intersection, and then perhaps the sun study. Create snapshots of these under the Presentation tab. Snapshot, choose a file name, set a resolution, and click Save. Create a storyboard or fly-through using the Storyboard Creator. Perform a sun study by going to Sun and Sky. Change the time of day, change the date, you'll see the shadows happen. You'll even see the light color, the light quality change. So finally, I'll restore the model extents, and I'll leave you with the final drive-through video.